No? All right. Yeah. Hello?
Yeah.
Perfect.
Hello. Hello. All right. Well, good morning and thanks for coming. This is the last, well, tomorrow is the last day, so thanks for being here. How do you all like the keynote today? It's good? Good. All right. So my name is Madan Armugam. I'm a program manager, and with me I have my colleague Sang. Sangshay, he's also a program manager in our team. We work at SQL Server, Microsoft SQL Server. The topic of the day is obviously to give an overview of SQL Server running in Windows Azure virtual machines. Now, how many of you attended the talk from Mark Russinovich yesterday? He gave an overview on Windows Azure virtual machines and network. Show of hands. All right. Okay, so I'll kind of give you a quick recap. I won't go into details of what Windows Azure Infrastructure Services is, but I'll give you a quick recap so you can get, come up to speed. But we'll focus in this talk mostly on SQL Server running in, Windows Azure Infrastructure Services. Now, infrastructure as a services is not a new thing, right? Amazon has been doing this. We have other providers such as Rackspace, and now Google is as well doing it. But Azure has some advantages in terms of allowing workloads, Microsoft workloads like SQL Server running in our infrastructure services. So we'll give a high-level overview. We'll go through a typical database application lifecycle. You have your database deployments on premises. You're looking to figure out what can I run in Azure. We'll talk about a little bit about migration, the tools and the capabilities that we're implementing. We'll talk a little bit about deployment. Once you decided what to move, how do you deploy in Azure? We'll have a couple of demos on that front as well. And then we'll also talk about performance. This is a key concern for everyone. I had a session yesterday where I actually did a deep dive. Interestingly enough, that session was scheduled before this session. I would have liked it the other way around. So I won't go into detail, but I'll give you a couple of slides on what are the key best practices. And same thing with high availability. We have a session later today that is focusing on SQL Server high availability and disaster recovery in Windows Azure Infrastructure Services. Sang is going to be speaking that session later today. So I'd encourage you to attend that as well. All right, so with that, let's get going. So the session objectives, really, we'll give a high-level overview of SQL running in Windows Azure Virtual Machine. Like I said, we'll talk about the different phases, the things that you have to think about if you are considering running your SQL Server database in Azure. And then we'll also talk about the best practices in each one of these lifecycle phases, right? I'm hopeful that is useful for you. Something that you can take back and use it right away. All right, so since only few of you in show of hands showed that you have tried out Windows Azure, I wanted to give a quick recap. Now, infrastructure as a service is an offering that Windows Azure introduced a couple of months back, and that is generally available since April. It has been in preview, it was in preview from last June to this April. So, a lot of customers started playing with it. But in essence, what is it? It's basically a true infrastructure as a service, which means you can rent a machine, a virtual machine, right? Just like how you do on-premises, especially if you're using Hyper-V, where you get to say, here's the number of CPUs, here's the memory, here's the number of disks I want, you get to do the same exact thing, no different. And the differentiating factor between Azure and other cloud providers is here you can actually move things back and forth. It's the same VHD that you can use on-prem on Hyper-V, that you can just throw it over to Azure and it will just work. If it works on Hyper-V, it should work on Azure, right? So that's the promise that we have. And the focus with Windows Azure Infrastructure Services is to make Windows-based virtual machines run fastest in Windows Azure. Like Mark Russinovich in his talk yesterday, he said that, right? We can say unequivocally that Windows Azure is the cloud provider with the fastest Windows Azure virtual machines for booting up. And you will see in some of the the demonstrations that we'll likely show. And the way we achieve a virtual machine persistence is by saving everything that happens in a virtual machine to a backend blob storage. Now, Azure Blob Storage is a service that has existed for a while, right? It has been a generally available service for the last 2-3 years. And what we've done is essentially taken advantage of that persistent service for implementing virtual machines, and you'll see why that is important. We also implemented certain capabilities in Azure platform to expose deploying highly available SQL Server databases, right? For example, if you're using Always On from SQL Server 2012, you're probably deploying an always-on cluster, or if you want to use database mirroring, right? Now, Azure provides some of the building blocks that is needed to deploy an always-on cluster or a database mirroring cluster in Windows Azure, and that's called availability sets. Again, as part of the demos, we'll actually show you a walkthrough of how to actually deploy a SQL Server cluster, if you will. A load balancer hooks for application scalability. So typically, availability is all about uptime, and scalability is about keeping up with demand of number of users using the database. Say you have a workload application that is OLTP, and you're expecting it to burst from 100 users to 200 users, right? Unpredictably. You want to be able to have the hooks necessary to scale. So when your number of users go from 100 to 200, your machine is not dying, your database is not unavailable, right? So we have a lot of hooks in Windows Azure Load Balancer that you can actually use to actually attain that scale. Again, we have a demo. Sung will actually show you how you can use always on in combination with load balancer hooks to get both availability and scalability. The last couple of things that I mentioned here is pre-baked images. Now, Amazon has this as well, right? No different. Most cloud providers have this as well. But what we have done for Azure, because it's all within Microsoft now, SQL Server has purposefully built-in optimized images for Azure, and that is why you are able to see that to deploy a SQL Server virtual machine, it takes about 5 minutes, right? End to end, it takes just 5 minutes for you to deploy a fully stood up SQL Server virtual machine that you can just take it and just move the data and go forward, right? And we'll talk a little bit about what are the foundational pieces, that we did in SQL Server product that allows you to do that. And by the way, all the changes that we made in SQL Server to run on Azure, it works on premises as well. If you're running on Hyper-V, they should just work. An example of that is sysprep, right? We've now implemented all the capabilities of sysprep that is needed, and that doesn't matter whether it's running on Azure, whether it's running on your own private cloud, they should just work, just as it is. And then the last point I wanted to kind of highlight is the secure hybrid connectivity. Again, if you had attended Rasinovich's session, he talks about this. So this is a foundational piece for Windows Azure Infrastructure Services. And the key value proposition in a nutshell is it allows you to expand your corporate IP boundary, which is your trust boundary, all the way to Azure. So you can extend it using a VPN device, a hardware or a software, into Azure, and basically that virtual machines get included in your address space. So if you have tools that your IT department has put together to address virtual machines, manage them, administer policies, they should just work, right? So this gentleman was asking the same question. I have all my investments on premises, and I don't want to reinvest in these kind of tools. Well, you don't have to. That's the foundational piece that is part of Windows Azure. And as you probably heard multiple times, all these virtual machines, including SQL Server virtual machines, are charged by the minute. So think about this. This is extreme price elasticity. If you didn't want to use enterprise because it was expensive before, now you can rent it by the minute, right? And a lot of customers are already taking advantage of it, right? So they will actually run a SQL Server Enterprise for half hour, do all the data processing, and shut down the VM. And the data is already stored in storage. So you only pay for the storage. And the next time you want to process the data, you fire up the virtual machine again, do stuff, and shut it down. And it's extreme, price economies in a cloud scale, right? So something you want to think about, especially for dev test. Given that it's a new environment, you probably want to test before you can kind of take the jump and put your production workloads. But even for dev test, that price elasticity is something that is very appealing to a lot of customers. And obviously we have different VM sizes, just like other cloud providers do, right? Before I do this, let me take you on a quick stroll on Windows Azure Portal. How many of you have played around with Windows Azure Portal? Okay, so I'll just quickly show just the virtual machine portion of it, right? So if you look at the portal, I logged into this portal, and you can see on the left there is a whole bunch of services that Windows Azure has. Now I'm interested in virtual machines, which is the topic of the session, right? To create a virtual machine is pretty simple. I click New, I choose Compute and Virtual Machine, and I have an option on whether I can choose from the gallery. I'm going to choose that. And right here, you see a whole list of platform-provided optimized images. You see a bunch of Windows software, right? You have the Windows Server 2012 R2 preview, which was announced. We even have the SQL Server 2014 CTP1, which was also announced, at Keynote a couple of days ago. So any one of these images, you should be able to just click. Couple of steps. You have to put your, virtual machine name, and that's it. It's going to, get started. And after 5 minutes or so, you'll have a virtual machine that you can just RDP in and get going. If you want to move some data into that SQL Server virtual machine to do some dev and test, you're essentially there, right? Now, contrast that with what you have to go through on premises. Now, a lot of private cloud environments do have this kind of agility, but at a different price point, right? Now, this virtual machine, if I spun this up, if I stop that VM, I'm not getting charged, right? So something that you want to think about. At the very least, I'd encourage you to try it out, right? There's a great MSD and dev test offer that's ongoing. It's completely free. You sign up. Take it for a ride and see, if that works out for you. All right. Now let's switch gears to what this means for SQL. Now, how many of you know about all the offerings we have in SQL Server as it pertains to cloud? Show of hands. Good. So this is a summary slide, if you will, on all the different combinations of offerings that we have, which could be quite confusing if you're new. You're like, hey, I have like 5 different things. I don't know how to decide between one versus the other. And this slide, the intent behind this is to convey a simple decision model on how you can figure out what is right for you. So what you have here is a simple chart, right? Or maybe a graph, if you will. On the left side, on the x-axis, I have what is called as high control. And by that, I mean, as an IT pro, do I want control of that machine, control of the SQL Server, where I can, fine-tune it, optimize it to my heart's content because my workload demands it. And on the right side is the other spectrum, which is low control. You don't get all the options to tweak it, but you have some options. But compared to the other end of the spectrum, it's low control. And on the y-axis, basically you have shared infrastructure. Basically, your virtual machine or your SQL Server is running on a shared multi-tenant infrastructure. So therefore, your cost is low. Or you can choose that you're running on a dedicated infrastructure, which is typically how it is in most enterprises, private clouds. And obviously, it's higher cost because, it's customized for you. You manage it. You have to buy the infrastructure. You have to manage it, right? So if you plot all the SQL Server offerings, and as you can see, the offerings are the good old classic SQL Server, which runs on, your physical machines. You can continue to run forever. It has a high level of control. And obviously, it's dedicated. You get to say what happens, right? The next step is you're virtualizing them. And you're saying, hey, you know what? I want to kind of put multiple SQL workloads in the same machine so I can maximize the return of investment for my hardware by putting these virtual machines together. And so you get some benefits. You're losing some control, but you're saving on cost. Now, infrastructure as a service is the public cloud version of that. Right? A lot of customers are doing this already in private cloud. Think of this as an extension of that in public cloud. You're still running your SQL Server and virtual machines, but it's not running on your own hardware on premises. It's running in Azure, right? So this and this are extremely compatible, right? And this is the value prop from Microsoft. And then if you take that one step forward, this is our platform as a service offering, where again, you're losing a little bit more control, but trading off for cost, right? I mean, if you see, this offering is much cheaper compared to all these three, right? And also, it's less configurable, right? We take away all that so we can kind of give you some a cheaper price point. And last but not least is software as a service, which is kind of your end destiny, where hopefully at some day you can focus just on your business application, and anything around database services is something that you can call in as an API. That's the vision that Microsoft is driving to. We are not there yet, clearly. Not for all applications. Most of the world is here, right? Somewhere here. But as we go through the journey, you will see that Microsoft will continue to offer this diversity of offerings so customers can pick and choose what works for them, right? Now, let's focus primarily on where we are now, right? A lot of customers today, including most of you, how many of you actually run SQL Server in a virtualized environment? This is good to know. I mean, I've been doing this talk for about 3 years. And 3 years ago, when I used to ask this question, you would probably see just one person or two person, the rebellious IT or database administrator, actually putting their database, not the production workload, but a database workload and virtual machine. And over the couple of years, I've seen this increase. I mean, roughly half of this room is already running SQL Server and virtual machines in some capacity. Maybe not production, but at least dev test or production staging, if you will, right? So with that context, since half of the world is here, how can we help them take advantage of the cloud economies, right? Like to be able to charge by the minute, right? How can you take advantage of the price point without having to rewrite the app? And these are the capabilities that we are doing, and you'll see throughout the session, we'll actually demonstrate some of these capabilities. Almost all these capabilities are available in SQL Server 2014, right? The CTP 1 that was announced. And then we will have another CTP 2 where we'll have some more features. The purpose of these features is to essentially help you migrate from where you are. If you're already running in a virtual machine, make it as easy as possible to try out Windows Azure, probably for dev test or if you want to, even for production, right? The first in line is cloud backup. Now, this is probably a very easy case to make, right? You have SQL Server running on-premises. You're taking backups. You probably have a maintenance plan or an agent job that runs every so often, takes log backups, full backups, and whatnot. The idea is pretty simple. What if we can do that, except the destination for your backups is an Azure storage? Now, there are immediately advantages to this approach, right? You're having a very cheap DR story, something that you may not have been able to afford, in your current environment, because Azure storage is so cheap to store this kind of cold data. Now, if you can directly from your SQL Server Management Studio or T-SQL do that, that makes it just as easy, right? The next step, say you've done this. So like, yeah, I get this. I'm doing the backups in Azure. It's very cheap. It's limitless storage. I'm good. What is my next step? Well, the next step would be to do an always-on replica in Azure. And how many of you are familiar with always-on or use always-on? All right. So for those who are not familiar, I'll quickly summarize what always-on is. Or how many of you actually use database mirroring? Okay. So if you know database mirroring, think of always-on is essentially the next version of database mirroring that was introduced in SQL Server 2012. It is much more capable than database mirroring. And in essence, essentially, it's a SQL Server high availability solution for groups of databases. And that group of databases is called availability group. And you can essentially create multiple secondaries, readable secondaries, active secondaries. You can take backup from secondaries, something that you weren't able to do with database mirroring, right? So that's the core essential value proposition of always-on. Now, the way it applies to Windows Azure is, if you already have an always-on deployment or a database mirroring deployment, you can actually put your mirror or your secondaries in Azure. And you're able to do that because SQL Server running in a virtual machine, whether in your private cloud or in Azure, is exactly the same. It understands the environment that you're running in, and you're able to compose this application topology that spans on-premises, private cloud, or your physical machines, and Azure. And why would you do that? The reason you would want to do that is, again, because you have a very cheap online disaster recovery solution, something that you may not have been able to afford before because you need to install a completely new data center, which is hundreds of miles away, keep it up and running. Well, now Azure is there, and it's quite cheap. You can pay by the minute. When disaster strikes, you can make that primary, right? So you have a lot of interesting opportunities now to be able to take advantage of cloud in a way that doesn't disrupt your existing on-premise installations. Your on-premise installations continue as is, but you're essentially putting one leg in cloud and see, how does it work for me? Is there any advantage for me? Is there any value that I can gain immediately, right? Okay, so if you say that, I buy this, I'm willing to try this, what's my next step? Now, one of the other features that we are actually investing in SQL Server 2014 is for a set of customers who are bleeding edge, they have scenarios where the SQL Server is completely present in private cloud. It's not moving anywhere. It's very mission critical. But they have few databases in that SQL Server that they say, not all the databases in my instance are, high priority. There are a few databases that, happen to be there, and I don't mind putting them in cloud. But at the same time, I don't want to install, tear away my existing instance, create another SQL Server instance, pay for that license, manage it. I would love to be able to keep my existing on-prem SQL Server instance, but have few databases stored directly in Azure. Now, that is the capability here. So your database and a bunch of databases in the instance stays in your local SAN or your private cloud, whatever your storage subsystem is. But you can pick and choose few databases, probably your smaller databases, and store them directly in Azure, right? So this is an extension of these ideas, but as a database storage, right? And you can actually mix and match these databases. The same instance that is running on-premises in your private cloud can manage both, and it wouldn't show any difference. The only difference that you would see is how you access that database file. You may see a difference in terms of performance of that database, right? And then the final end goal, obviously, is to be able to move your database instance, including the databases, to run fully in Azure IaaS, if you so choose and if your business case needs it, right? So as you can see, these are all incremental next steps for you. These are capabilities that you'll have in SQL 14, so you can pick and choose at your own pace and figure out, how far do you want to go in this journey. Now, we also have, and we'll show a demo of this, we also have a feature, a very simple SQL Server Management Studio feature that allows you to right-click your database. From SSMS, you pick an on-premise database in your SQL instance, right-click and say deploy to Azure VM. And you'll see a demonstration of that. It actually hides all the complexity behind going and opening up ports in Windows Azure, creating virtual machines. All you need is your on-premise SQL Server instance, which I'm hopeful that you all have already, right? You're all managing that, and a Windows Azure subscription. That is it. With those two things, you should be able to go completely, deploy a copy of a database from on-premises to Azure. And that, again, is to, allow you to kind of lower the barrier so you can test Windows Azure, get to know what this is about. Is this something that will work out for you, right? All right, I'll keep moving. So after this set of context, I wanted to kind of go through the rest of the session in terms of life cycle stages, right? Primarily from a SQL Server point of view. So I'm not going to cover the whole Windows Azure stack. There is a lot of good information that is available. If you didn't attend Rasinovich's session, I'll encourage you to download the slides. He talks about from an all-up Azure platform how you migrate. But my session focuses on migration from a SQL Server point of view, right? And I'm going to do a deep dive on backup to cloud, right? So backup to cloud, a lot of folks immediately react and say, I don't want to do anything with the cloud because it's far away, I don't see it. But one of the things that we wanted to say to you is, we've made it so easy without you losing control of your environment, right? So what is delivered? It's basically a simple T-SQL enhancement. So most of you, almost all of you, I'm sure, are backing up your databases. You probably have a T-SQL statement, something like this, backup database to disk, right? And you say, here's my folder. You probably have automation built on top of it with agent or maintenance plan. It probably is taking every 5 minutes, every 10 minutes, whatever the requirement is. Now, all we have done is basically change this statement to also support a URL. So as long as you have a storage account in Windows Azure, and I'll show you in a demonstration, you just replace your disk statement to a URL. You create a credential, and I'll show you how to do this. And that's it. Nothing else. Your database from on-premises will be directly and securely over HTTPS, back up to Azure. Now, and you can use any of the Azure Storage Explorer tools to see that the backup is already happening. So let me do a quick demonstration of this. All right. So the first thing I'm going to do is create credential. Now, create credential is a SQL statement that has existed forever, right? It's basically, a security object that allows you to create credentials. All I'm doing is using the T-SQL to create a storage account credential on how I would access Windows Azure Storage. Now, where did I get this? I mean, this whole cryptic thing, right? And I'll quickly show you how to do that. So basically, if I want to create a storage account, I first sign up for Windows Azure. Once you sign up for Windows Azure, you get logged into this portal. I go to, a storage right here, if you go here. And I have a bunch of storage accounts here, right? So you should be able to create a new storage account. And once you have a new storage account, you would have in the portal a way to kind of configure it, monitor it, and all the different containers. Now what I'm going to do is, this is a storage account that I've already created, but I want to know how to access this storage account, right? So I'm going to click on this button, say, manage access keys. And what you see here is the name of the storage account, a primary access key, and a secondary access key. Now, all I need to do is just copy this, right? And then paste it here, which is what I've done here, right? So all I'm telling SQL Server is, hey, here is a location, and here is my, the key to access that storage account. So I'm going to execute the statement, right? It's an existing T-SQL statement, nothing, nothing different. Then what I'm going to do in the next statement is backup database. I have a database called MyDB, and I'm saying here is the container, right? So in order to explain what container means, I'm going back to my portal, and if I see here, I'm going to go here, and I see a dashboard, a monitor, a configure, and a container. Containers are simply, think of it as an equivalent to folder inside a storage account, right? Now you can see inside my storage account, I have 4 containers, or folders, if you will, and I have a folder for backups, right? So you can obviously create a new folder or a new container by saying add container. You can also decide whether you want it to be private, public, or public blob. We highly recommend for backup to blobs to keep a private container, so it's protected and it's not exposed without appropriate credentials. Now I've created already a container called backup, right? So I type in my actual storage account URL. I say here is my container, and I'm naming my backup as my DB1, and I put the date for tomorrow. Because I want to kind of have a backup scheme where I can be very explicit about when the backup was taken, right? Now, all I have to do is just run this, and you'll see from the experience point of view, this is no different than a backup that you've taken before, right? If you look here, this is the same exact log that you would have seen, right? If you're taking it on premises, on a disk. Nothing different. So we made it as easy as possible. It doesn't require you to go rewrite your scripts. All you have to do is change your disk statement to a URL statement, and that's it. And obviously, once the backup is there, you should be able to use any one of the tools that we have. And like, for example, I can use the portal tool, and I can see that the backup that I took is just here, right? MyDB1 2013-06-28.backup. Now you also have tools such as Storage Explorer. This is a tool that is in CodePlex. If I go to backups, I see that here as well, right? So it's as simple as this. It's a backup that you can actually transfer back and forth between Azure and your on-premises private cloud, if you will. Yes, question?
One of the most common things you have to do when doing backups in on-premise is checking for the backup integrity.
Yes.
With headers only,
yes.
etc.
Yes.
Is this feature fully orthogonal in terms of not only the backup action, but the restore itself can also reference?
Absolutely. Absolutely. In fact, I didn't show the demo, but if I do a restore, this should be, yeah. I mean, obviously, the reason you back up is so you can restore. It's fully orthogonal to, I would even say it's fully built in as part of a backup, statement that we have. So it's integrated with the backup statement. So it's anything that you work with backup, formatting backups or header-only backups, all of that should work. In fact, even compression should work, right? And if in future we support, so for example, if we support encryption or any additional hooks into existing backup, everything should work for URI as well. It's a good question. All right, so now I'm going to switch back just to make sure that I'm keeping up with time. So I wanted to kind of, as we go through this session, also give you some of the best practices based on what we've learned from our own testing as well as customers using it. The backup to cloud demo that I showed, this was released in January as part of SQL Server 2012 SP1 CU2. So you should be able to go try it out now. In fact, if you want to make it easy, you should be able to download the SQL 14 CTP and try this out. I mean, that's what I have done. I just created a VM of SQL Server 2014 CTP1 and did the demo. So in terms of best practices, there are a set of best practices around how you manage the storage account, right? It's not independent of SQL, but it's good to call this out here. Make sure the access level is private. I showed you how to do that. Carefully choose the location of the storage account that you're running. If you're running SQL Server in Azure VM, if you care about performance, make sure that they are located in the same region or same data center, right? If you're putting this in a different data center, make sure you're aware of why you're doing it. It's a valid use case if you want a disaster recovery between 2 data centers. But if that's not your use case, make sure that you put it in the same region or same data center. Backup compression works, like you said. It's just a backup feature. It's just getting stored in Azure. We actually see a lot of advantages using backup compression in this context because you pay for what you use in Windows Azure storage, right? So if you can compress, why not, right? So you're minimizing on the cost that you have on Azure storage. And all the data in to Azure is free. So literally, you only have to pay when you do a restore, right? Or if you're copying the backup file outside and keeping it on premises. The last thing is important. This is one of those things that we have learned, as feedback from customers. Say, for some example, you're sitting in your private cloud and there is a network hiccup. You're doing backups and the backup was interrupted. Internet connectivity loss or whatnot. What happens is, you actually have to go and break leases, right? You basically, when SQL Server is taking a backup and say it's 50 gigabyte, a database file, maybe it takes a few minutes over the internet, and something happens, right? Somebody actually literally pulled the plug, or something happens. Now, what happens is SQL Server, when it starts the backup activity, it has an infinite lease on that blob, on that Azure storage. So it can actually make sure that nobody else is accessing it while it's writing backups. But now, if it's interrupted for some reason, you actually have to go and break that lease. So when you restart the backup, you can actually complete that operation. Now, in our documentation, we have given you a very simple way and scripts to do that. And in future, we'll actually make this, the breaking of the lease action directly from SSMS. We haven't done that yet, but in the next, in the next few months, we'll be actually implementing that. In terms of performance of the backup itself, this is a question that I get asked all the time. Hey, my backup is traveling all the way over internet. There is network latencies involved. What can I do to kind of make it faster? A couple of things that you want to do is, one is enable instant file initialization if you haven't already. Instant file initialization is a knob that you can turn on from a Windows OS point of view. It requires a specific privilege, right? And there is explicit documentation. We also have a white paper which shows you how exactly to do it. You want to turn that on anytime you're dealing with Azure storage. The reason I'm saying that is Azure storage subsystem automatically zeroes it for you. So you don't want SQL Server or Windows Server to do an additional level of zeroing. It's actually wasted activity, and not only that, it takes time, right, because it's a multi-tenant service, and you pay for it. And there is no reason why you should do this, right? And then the last thing I wanted to kind of call out is people always ask, hey, I have a 500 gig database. How long is it going to take backup? It's very hard to kind of put a number because it depends on your internet connectivity from your private cloud or your physical machine to Azure, right? But what we can tell you is we've optimized everything that we can within SQL Server and in Azure storage. So literally, the only limiting factor is how good is your internet pipe, right? So it's as good as your internet connection is what we could say. We've actually provided a set of steps so customers can actually go and benchmark themselves for your internet connection. That's something that I'd encourage you to do. All right, so we did the demo already. Now let's shift to the next stage. Say you already migrated a bunch of data. Now we are at a point where you're saying, hey, I want to actually create the SQL Server VMs, right? So let's talk about that. So basically, there are two paths for you. Very simply put, there are two options for you. One, you start from what is available in the gallery. I showed you the list of the VHD images that you have, pre-baked SQL Server images, different versions, different SKUs, all charged by the minute. Even Linux, Windows Server, anything that you want, you can potentially start from there. We have currently 7 paid images, per minute images, and 2 CTP images of SQL Server 2014, right? Any one of them, you should be able to click, and within 5 to 10 minutes, you should be able to have a virtual machine ready to go, right? All the virtual machines running SQL Server are configured with the default options in the setup. So what we do and I'll talk about it in a separate slide in a bit more detail, we complete the setup for you through sysprep and leave you to just specialize it, right? So in the portal, you're asked certain information on, hey, what's the username password? What's the size of the VM? That's the last piece of information we need to complete the provisioning process, and that's all we do. Now, for some reason, if you've created the virtual machine and you say, what, I actually want to change that, you can do this, right? In some cases, it might require a reboot. The actual installation media for SQL Server is actually stored in the virtual machine. So you can always go back and say, I don't want analysis services. It's installed by default. Nobody's stopping you from doing that, right? We said, we support multiple SKUs, it's pay per minute. The images that you see in the gallery at any point when you go to the portal, they get refreshed on a monthly basis. And what we do there is we accumulate all the patches, the security patches, right, that Windows Server has or if SQL Server has, and we install it in the latest and greatest gallery image. Now, that doesn't mean that the VM that you created from the gallery image is going to be automatically updated, right? That is your job, right? But what you could do is, if you keep your data in a separate drive, you can just shut down this VM, create a new VM from the latest gallery image, and just attach that disk, right? So a lot of customers actually do that. So they have scripts that essentially does it on a monthly basis, and they provide the disk layout for SQL Server in such a way that they can actually do this in a much faster way. Now, the other option for deploying is bringing your own. For some reason, you say, I like this pay-per-minute, but you know what? I'm a big enterprise. I want price predictability. I already have enterprise licenses, license mobility, where I have a certain number of Azure credits. I prefer that. Okay, that's good. And typically, what you would do is you already have VHD images on premises. All you have to do is sysprep them and throw it over to Azure. A lot of customers already do that in private cloud, right? And this is where one of the key deficiencies we heard from customer was, hey, SQL Server sysprep is not complete. I can do database engine, but I can't do analysis services, or I can do SQL Server clustering. The good news is, in SQL Server 2014 CTP1, we've already fixed a lot of this. In SQL Server 2014 CTP2, we'll be completely supporting with SQL Server sysprep in a clustering mode. So with this, we have completed all the hooks that you would need that you can configure a fully configured, you can sysprep a fully configured SQL sysprep, a cluster or a SQL sysprep system, either for your private cloud or in Azure, right? And you can actually move them back and forth. So typical process for bringing your own image starts with sysprep. Like I said, we support analysis services, integration services, management tools. So these capabilities were shipped in January as part of the cumulative update for SQL Server 2012 SP1. And we also made some performance improvements. So when the end-to-end provisioning of a SQL Server with sysprep is much faster, almost 5 to 6 times faster than what you saw in previous releases. And then what you typically do is say, for example, I have a new cumulative update for SQL Server 2012 SP1. You slipstream that package. I'm hoping most of you know what that means. It's basically a setup step that allows you to kind of sysprep the latest bits, download the latest bits, and inject into your existing deployment. You run your SQL Server setup, right? It does the following things. It invokes the image preparation. You get to select what features you need, and you generalize the image. And that's the point where you can actually move this around. That image is completely portable. It's generalized enough that you can put it in Azure, you can put it in a private cloud, and then you can specialize them. So it's at a state where you can clone as many copies as possible, right? And in the upload to Windows Azure, we have an existing PowerShell script, right? A CS upload or an add Azure disk, I believe. There are a few common methodologies on how you can upload a VHD, if you will. Now, all of this is scriptable. It doesn't mean you have to go through the UI and click one by one. It's all scriptable. So typically what we have seen customers do is they figure out what configurations they need, what configurations are supposed to be for a compliant IT system, and then they script it out. So next time somebody comes to you and say, hey, you know what, I want a machine, you just press a button, it runs a bunch of PowerShell scripts, and you create a generalized image. And now what you can do is throw it over to Azure and say, hey, here's a machine. And they probably won't even know if you have it connected in your internet, right, or a CorpNet. Yep.
What about those scenarios in which you already have the virtual machine in production?
Yep.
And you want to say, you know what, I'm getting rid of this old server because I have an upgrade.
Yep.
So I want to bring the already existing virtual machine in production and put it into the cloud.
Yeah. No, it's a great question. So the question is, hey, this is a virtual machine that's already running on-prem. If I want to go create a generalized image, it's more work for me. I just want this virtual machine to run in cloud. You could do that. If you're running Hyper-V, you basically already have a VHD. It's not a generalized sysprep VHD, but it's a VHD. It's a running disk, really, right? So you could do that. You can actually take the disk, move to Azure, and it should work as long as the disk is not referring to something unique about your on-premises configuration. If your disk is all it is showing is, I have a system drive, I have a bunch of data drives, and here are the requirements, you should be able to just throw that VHD. Each VHD represents a single volume, typically on-prem, right? So say, for example, I have a OS VHD that has SQL Server installed, a bunch of applications installed, and you want to just take that VHD and move it to cloud, you should be able to do it. What you cannot do is once you move that to Azure, you cannot stamp out multiple clones of that because it's a running machine. If you want to do that, if you want to stamp out clones of it, what you do is you take the disk, put it in Azure, create a virtual machine out of a disk, and then you sprep within Azure. You can do a capture workflow which would create a generalized sprep image, and then you can stamp out multiple. But yeah, the short answer is it is absolutely possible, it is supported, and a lot of customers actually do that. Because they say, you know what, I've already done this. If I'm starting from scratch, great, I'll do. If I'm using SQL Server 2014, I'll use this prep. But if I'm already having this, I want to just throw that out. I want to do this.
The reason why I'm asking this is because one of the challenges in production world is patching up.
Yes.
And you, of course, want to make sure that you test thoroughly.
Yes.
So if you were to have the chance to be able to take your production environment,
yes.
put it into the cloud,
yes.
and begin patching to simulate
yes. yes.
that really helps a lot in management.
No, that's a great point. I mean, what this gentleman is saying is, I want to do dev test. I want to try it out, and I want to do it in Azure before I know whether I can take this patch. And that's a fantastic use case where I know you should be able to use Azure to do that. Now, deploying database. So this is one of those features that we are adding in SQL Server VM, right? And Sang is going to show a demo of this. The primary reason why we built this feature is because customers were asking about two scenarios, right? I'm new to Windows Azure. You know what? I don't know all this Windows Azure thing. I can sign up for a subscription, a free subscription, but it's a lot of new stuff, and I don't have the time. I have SQL Server. I like what they say about Windows Azure. It's cheap, but I want to try it out, but I don't have the time, right? So we said, okay, how can we make it as easy as possible for a SQL Server user? Right from where they are on premises, right? So a person who's new to Windows Azure, but I want to try SQL Server running in an IaaS VM. And the learning curve is steep, and our challenge was, can we make it simple? Very simple, existing skills. The other scenario is, I'm an experienced user. I just want to do something quick in Azure, and then I'll bring it back, right? Like the example that this gentleman gave, right? I know a little bit about Windows Azure, but I want to do something quick. It's temporary, but I'm going to bring it back. I'm doing some experimentation, testing, dev test, right? But the problem with that particular persona has is, man, if you're asking me to do 27 steps, forget it. I want to do dev test. A dev test should be something that is turnkey. 5 minutes, I get something, I do something, I learn something, and I go back to my production environment, right? So those are the two scenarios that we are going after. And the solution that we are putting together is a simple, write in your SSMS, systems, SQL Server Management Studio, a wizard that we built for deploying a database to Azure VM. To talk more about it, I'll ask Sang to take over.
Thanks, Madan. To get started, how many of you guys have actually tried deploying or migrating an existing on-premise database into Azure? 1, 2, 3. Okay. How was that experience? Disaster. Okay. Depends. Okay. So it's a good point. It is pretty complicated, and to kind of show you we recognize that too. So one of the ways that we tried to solve that complexity is through, as Madan mentioned, this new wizard in SSMS. So this will quickly just show you all the things that the wizard does, and also for those of you who haven't tried it yet, all the things that you would have to do to set it up, and also shows you how the wizard takes care of it. So this is the basic kind of environment right now that we envision a lot of you guys probably fall into. You probably have some form of corporate network. This corporate network probably has 2 levels of protection. One level of protection for your database, which is probably behind some additional firewalls. And then, of course, there's a level of protection where you are in, where your desktop machines can access the internet and such forth. And then, of course, there's the Windows Azure boundary. So you, as a DBA, you want to get your database backed up into the cloud. So Windows Azure, of course, as I mentioned, has a boundary. And for you to be able to deploy and move stuff into the cloud, there's this concept of this management certificate. So you can then go to Portal, log into Portal, and you can get this management certificate back, which lets you automatically, lets the wizard basically automatically bypass the Windows Azure layer, connect through, and start listing things from your subscription. And on your subscription, of course, you have virtual machines. So this wizard allows you to do one of 2 things. You can either use the wizard to create a brand new virtual machine to move your database to, or if you have an existing virtual machine that you want to use, it'll let you choose it. It'll let you choose that existing machine and then migrate a database directly to it. So for your wizard to connect to the virtual machine, there's actually still a whole bunch of stuff that's blocking you, right? You have passwords, you have firewalls, and things like that. We're introducing in SQL Server 2014 this concept of a cloud adapter, or this new feature, which is called the cloud adapter, the SQL Server cloud adapter. This cloud adapter will take care of a lot of the local administration on your behalf, such as setting up the firewall and also setting up local user accounts. This then lets you just directly connect through, so you don't need to worry about actually physically managing anything. Of course, you have your own firewall within your database to worry about, but assuming you have the password and the right permissions to take care of that one. We then use this kind of intermediate share. So the concept here is that you still don't want to expose your database server itself to the wider internet. So we actually have an intermediate share where we take a backup locally and then copy the backup files onto this intermediate share, and then the wizard itself, your desktop workstation, can then access that copy and then upload it on your behalf. So you can see that happening here. The administrator issues a backup command. The backup command backs it up directly against the file share. The file share, the backup's created there. It gets uploaded through the SSMS wizard. We use your subscription, and you specify a storage account for it, and we copy the database backup onto this blob. We do this for multiple reasons. We want to make sure that there's redundancy, and we want to take care of any failures. So this kind of separates that concept of trying to do a restore from your backup locally. We actually can restore directly from we have it all in Azure already, so we take care of all the file copies. We take care of all any issues that might happen while uploading itself. Then Cloud Adapter jumps in again. Cloud Adapter will then copy this backup file from your blob storage onto your virtual machine local disk, and then perform the restore for you on your behalf. Once this is completed, it'll start cleaning up, and after everything is done, it'll issue you a nice report saying, hey, I'm finished. Here's what happened, here's what didn't happen, and it'll also give you a detailed log. So hopefully that makes it a lot easier, especially for those of you guys who ran into it before. Hopefully that makes it a lot easier for you. At this point, I'll walk you through and show you what it actually looks like.
Another one.
This one?
No.
Gotcha. Thanks. So as you can see here, I'm first going to show you what you have to do in Portal to set things up. So I created this existing virtual machine just to save some time called SungHDWDB. This will be the target where I want to migrate the database to. This virtual machine, you'll see here, I created an additional endpoint for the cloud adapter. By default, we use port 11435. I'll show you where that comes in later. But basically, you have to open up a port on your virtual machine so that we can upload files to it. And again, this is if you're using an existing one. If you're actually going to create a new one, if you're going to use the wizard to create a new virtual machine, we'll do this on your behalf. So now I go to my source server, and you can see here that this is a machine that I'm running that has my existing database. I have 2 databases. I'm going to try to migrate this second one. And this database is pretty simple. It just has a single table, which is called My Products. And I inserted some rows into it, and this is the results that you see from it. So just has these 4 data points. To launch the deployment wizard, you can simply right-click on the database, go to Tasks, and you can see here in SSMS, we have this brand new task available for you, which is Deploy Database to Windows Azure VM. You click on that, and you first connect. Again, this is kind of assuming that your database is actually remote from your machine. For simplicity, I actually just have it on one machine. But assuming that it's remote, you then connect to the machine that you actually want to use as a source. This will automatically find the databases that are on the machine that you can migrate. So I'll select this one, MyAppDB2. And again, here is where you specify, as I mentioned, that external file share. In this case, again, since everything is just all one machine, I'm just going to put to something local, since just for simplicity. But if you are running the wizard separately from your database server, you would have to find a machine that actually both your wizard and the database server can both access and have a share that both of them can use. Now you have to connect to Azure. So there's several different ways to connect or to get connection info to connect to your subscription. If you already have a certificate that you've deployed on it, that's the easiest. You can just select it. If you don't have that, if you have a publishing profile, if you've previously downloaded a publishing profile, for example, to use with Visual Studios, you can select that here, and then we'll use it automatically for you. If you have none of those things, then you can simply click on the sign-in button, provide your credentials to Azure, and then we'll take care of creating a certificate on your behalf and setting that up for you. Then the final step is selecting which of your subscriptions you want to connect to. And we will validate everything, make sure that we actually have access. And once it does, you'll see here we start populating information from your subscription. So in this case, I actually have a few different cloud services in that subscription. I am going to select the second one, preparing for the demo. Once you select that, you'll see it actually automatically finds which virtual machines you have in that service. So I actually have several. I am going to use the first one here, but I have several of them here. And which storage account. So again, this storage account is where you're placing that blob when you're uploading it. Once you've selected it, you provide credentials for how you connect into that machine. And you'll see here again the cloud adapter port, as I mentioned earlier. By default, again, it's 11435. You can change it to whatever you want. The important thing is that you have a magic endpoint on the other end. Now, I mentioned, of course, that you could actually use this to create a brand new virtual machine. What you would do here is instead of selecting a cloud service, you actually would just put in a new name. If you put in a new name, we'll actually bring up a wizard, and then you can actually I'll show you here quickly, demo test. And if you do this, and you click on settings, what this will pop up instead of that login dialog box is this quick dialog that lets you actually specify additional information about creating a virtual machine. So you can see here that, let me zoom in. You can see here that you select the DNS name of it. You can choose from any of the platform images or user images that you've uploaded. One of the key things to remember here, though, is that because the cloud adapter is new for SQL Server 2014, you actually have to use SQL Server 2014 as a target. So you should ideally be choosing, whatever you choose here should be a SQL Server 2014 or have SQL Server 2014 running in it, because those bits will have the cloud adapter. Or if you have previously created a machine or uploaded binaries, have had manually installed the cloud adapter.
Important point here is you don't have to go to the portal to create the virtual machine. You can do right from your SQL Server Management Studio. So.
And then you enter your connection information. You select the size of the VM that you want. You select the location of where you want it to be created. When you do choose the virtual machine, it does also pop up additional legal text, such and forth. And we'll generate a certificate on your behalf. So in this case, since I already have a virtual machine, I won't be using this. Let me go back and select my test subscription. Make sure everything I can still log in. Okay. And then you'll see here that this now has read from the target server and has pre-populated information such as the instance name, and also it created a a name of database that it'll upload it to. You can change the name, of course, if you want it to be named something differently when it comes out on the other side. Now, and that's it. That's all you have to do. So this gives you a quick summary of everything that you've selected, and it'll go through and it'll upload it for you. So it goes through the steps that we showed you on the wizard. The first thing it's doing here is validating everything works. These steps here, it would be provisioning the virtual machine had you selected creating a new virtual machine. In this case, this is just going through and making sure it can access everything and all the settings are correct. Also applying the configuration. As I mentioned, like we update the firewalls and such forth. And then finally, it uploads. So this is now copying your backup file from your share all the way up to the blob storage. And it's now restoring. So this restore typically takes some time. So instead of that, I'll show you what it looks like on the other end. So you can see here, this is the SungH DWDB that I selected previously. This now has, I had previously used the deployment wizard to migrate the same database. And so you can see it was created here. And If you select from it, it returns the same data. So it's very simple, it's very easy to use, and it lets you very quickly deploy a database from your existing on-premise onto onto Windows Azure, so you can use it right away. Now, the benefits of this, I keep using the wrong one.
The last one.
The last one. The benefits of this is you don't actually have to know much about Windows Azure. We take care of all of that for you. You basically need to just know your login, your Windows Azure login. Once you log into Portal, we can create all the certificates, we can create all the access for you on your behalf. We made this to be fault redundant. So there's several points which it could have possibly failed due to network connections, due to typing in different things, various reasons why things could have gone wrong. We made sure that the wizard is resilient to that so that we can actually recover from it and retry. And we store things in these intermediate locations so that we can continue from those places in case if there is something that occurs. We don't mess with your existing data. So this is really a migration tool. It's not destructive in any way, so you can keep running it, and you can move whatever databases you want to it. It's highly scalable. You can use it up to 1 terabyte databases, but please be aware that, of course, your performance is going to be very slow due to the fact that it has to copy the 1 terabyte database up. And the 1 terabyte database limit is a X drive limit. It's the limit of how big a drive can be on your virtual machine. So with that, I'll turn it back over to Bada.
All right, thanks, Sung. So just to wrap up this section around deployment, I wanted to kind of encapsulate, just like how we did on the migration section, some of the best practices. We had a question earlier on the difference between a VHD image and a VHD disk, right? I mean, this is a little confusing term when you say VHD, it's a virtual hard drive, but there is 2 mechanisms. One is a fully sys-prepped generalized image that you can kind of throw around anywhere and create a VM out of it because you're actually specializing when you are creating the VM, versus a disk which is already specialized, running on-prem or anywhere else, and you can only create that virtual machine, right? You cannot create multiple copies of it, right? So be aware of that. A lot of times customers get into problems when they kind of lose track of what is a VHD image versus what is an actual running disk. Planning your deployment configurations, plan it ahead, right? There are currently, because of the fact that Windows Azure Infrastructure Services is just recently generally available, there are some settings that are static and can be done only in the startup, only when you create the VM. An example that I'm giving here is, for example, if you want to create a couple of virtual machines and have them connect in the same virtual network, you have to do it when you're creating the VM. If you don't do that, there is no way to go back after you created the VM to connect them, right? So there are some limitations that are there today, especially around deployment. So plan ahead, right? Otherwise, the workarounds are quite cumbersome, if you will. The last thing is we would highly recommend you to enable remote PowerShell. It is, if you go through a creation of a virtual machine from a portal, it is enabled by default. The reason we suggest that is it gives you tremendous capability to script, to access your virtual machine, configure all through PowerShell as opposed to going every single time through portal or REST API. All right, so let's move forward. If I can move forward. All right, so performance. So this is going to be a very interesting topic for SQL Server. Again, what I've done is I've kind of compressed all the things that I talked about in a specific session on performance that I delivered yesterday into a single slide on the best practices. I'll go through that. Now, obviously, we won't have time to go and talk about every single best practice that we are recommending, but I'd highly recommend, if you're interested, to go watch that session, download the slides. And that session is based on a white paper that we released earlier this month, right? So I'll highly recommend to kind of go talk about that. But anyway, to quickly capture on performance, we have various sizes of virtual machines that are available today in Windows Azure, right? And as you can see, here are the configuration specifications. How much CPU, how much memory, what is the disk space for virtual machines, and this refers to the D drive or the temporary drive. And then the allocated bandwidth. This is an important thing to consider when you think about performance, because in virtual machines in Windows Azure, all your data is stored in Azure storage. And the connection to that is over network. So this becomes the determining factor of your performance, especially disk performance, right? So something that you want to be aware of. And so you can have realistic expectations on what disk performance you can get out of a virtual machine of a particular size. Now we also have the data disks. and you can essentially have anywhere between 1 to 16, and you see the limits there. And today, the published guidance on the maximum number of IOPS you can get per data disk is 500 IOPS per data disk. So you can see that if you're adding 4 disks, you have around 2,000 IOPS, which is reasonable for a small tier 2, tier 3 apps, but it can go all the way up to 8,000 IOPS, right? So these are current published maximums. Chances are when you do your own testing, you'll probably see that you can get more. But what I would suggest is plan for 500 IOPS, because as changes in the platform happen, what the platform will make sure it will give each of the customers is up to 500 IOPS, right? Anything more than that, you're essentially getting a free ride today, right? So plan around 500 IOPS so you don't get into trouble when changes in the platform essentially brings you down from 1,000 IOPS to 500 IOPS, right? So let's go through quickly the performance best practices. This is a single slide version of that entire white paper that I talk about, which I'd highly recommend, right? If there is one takeaway that you want to take from here, make sure that you copy this link, go download. We have done a lot of tests and worked with customers to kind of capture these best practices. Okay, the first thing is, what drive should I use? A virtual machine in Windows Azure has 2 different kinds of drives, actually 3 different. There is a system disk, there is a data drive, which is temporary, and then there is the data disk, there is a temporary drive that is D:, and then there is an optional set of data disks, right? Our recommendation is for smaller DBs, and by small we mean less than 10 gigabytes, you can put it in C:. For anything bigger, just put it on a data disk, right? The disks that you will attach and create. We're saying don't use D:, the temporary drive, for anything related to a database, even for TempDB. Now, you might think that, hey, this is counterintuitive. TempDB is temporary. I don't really care about, what is stored there. That is correct. But the problem is, a lot of workloads, SQL Server workloads, take a dependency on TempDB. Like table valued parameters is a great example. There is so much contention on TempDB. And from that point of view, the performance of where your TempDB is needs to be predictable for your entire SQL Server application, right? And the problem is when you put this on a D:, which is a temporary drive, not only it is not persistent, but it is not predictable, or not as predictable as your data drive or C drive, right? And the reason is the D:, is essentially a disk that is actually present in a local physical machine. And if this virtual machine were to crash for whatever reasons, or if it was going to be rebooted, you don't know where that virtual machine is going to be reincarnated. So you can't depend on that particular D:, for your performance. Also, if you decide to put your TempDB on that drive, you have to explicitly tell your service account to go create a folder. So it needs some access permissions. Chances are, when that virtual machine gets reincarnated because you rebooted or it failed, you won't have the same ACLs, right? The same privileges to be able to create. So in order to avoid all the problems, our recommendation is just put it on D drive. You should be able to get same performance or better in a data disk. For I/O-intensive workloads, we say leave the default setting. The default setting for the data disks in terms of cache is all caches are disabled. So that's what we're recommending for high I/O-intensive workloads. Now you can wonder and say, cache helps me in terms of read. Why are you saying don't use cache? Well, what we found out in our testing and also from customers is the size of the cache is limited. So, which is why we are saying if you really want high intensive I/O from your data disk, chances are you're going to flood that cache, and especially if it's a random OLTP, read and write workload, the cache is not going to help. In fact, it might actually hurt your performance. So that is why our recommendation is to just leave the default, right, which is the cache disable for data disks. There is another question that we get asked, like, hey, should I use single data disk or multiple data disks? Now, what do I get, one versus the other? The simple answer is, if you want IOPS for more than 500 for your SQL Server data, stripe them. And if you're striping, use SQL striping, right, which is SQL Server file groups or files. That gives you, the access to, more than 500 IOPS while keeping the storage management simple. But be aware when you go through that path where you have multiple data drives striped as a single volume, either through Windows striping or SQL Server file groups, you have to be aware that if you have enabled geo-replication on those blobs that is actually storing your drives, you won't guarantee consistency. The geo-replication feature in Windows Azure replicates each disk on its own individual boundary. They are not necessarily synchronized. The fact that you within the virtual machine has striped is something that Windows Azure Storage has no clue about, right? And it is very difficult to kind of synchronize back and forth. So something that you have to be aware of. Not all customers care about having geo-replication of their Stripe disk, but if you do, this is a limitation that you should be aware of. And another question that I constantly get is, hey, can I use multiple storage accounts and disks from multiple storage accounts inside a single VM? Now, we don't see a reason why you should do that, because the current target within a storage account in terms of IOPS is 20,000 IOPS. Now, for 80% of SQL Server workloads in the world, that should be good enough, right? What customers have tried to experiment with is, hey, can I try different storage accounts? And the reason they typically tend to do that is because, that flexibility is available in the system. But what we've been telling, both from Azure team and SQL team is, if you're doing that, then essentially there is a bug in our system, right? You should be able to get easily, 20,000 IOPS from a single storage account. So there is no reason for you to use multiple storage accounts. So that is our recommendation. Definitely use SQL Server data compression, right? This obviously reduces the number of IOs that you make to the disk, which is probably your most expensive performance aspect of your application. Also, in terms of cost, it saves you money, right? There is no reason to not compress here. Obviously, it takes a bit more CPU cycles, something that you have to be planned for, just like how you do on-premises. And final thing that I want to say is a lot of customers compare performance in any cloud, whether it's Azure or Amazon, to on-premises. Hey, I took my SQL Server application on-premises, I ran it in cloud. It's only 50% of the performance on-prem. Chances are you can get as close to on-premises performance, but the key thing that you will see is it is variable, right? There is always going to be fluctuations in terms of what you get in terms of performance, and this is true for any cloud provider. And the reason that is the case is because all cloud providers, they have a storage subsystem that is multi-tenant by nature. This multi-tenancy is what is inducing this variability. So what I would suggest is when you're thinking about a workload to first move into Azure, pick a workload where you can actually live with this variability. You can do your own testing to kind of find your upper bound and lower bound, and then decide what are the workloads that you need to move and what additional tweaks and configurations you have to make. Again, just to highlight this point again, definitely take a look at the white paper. I'm just doing a summarized version of this in the slide, but there's a lot of good info here that you can actually immediately take advantage of. All right, so let's quickly go through the high availability area. Basically, there are three scenarios when you run SQL Server in Windows Azure Virtual Machine. The first is you're saying, hey, I'm running SQL Server in a virtual machine. I want to get more high availability than what a single virtual machine can give, right? Basically, or always-on deployment. So getting high availability within Azure, right? So you should be able to do this with, database mirroring or always on, it doesn't matter. And what it gives you is within a region, you have high availability. If one of the VMs goes down in Windows Azure, there is another VM with SQL Server running that will continue to service your workload. The second thing is, hey, I want a hybrid situation. On-premises, my SQL Server deployment is continuously running. It's always on configured. I want to put a replica, a secondary in the cloud, right? And that is the scenario here. Again, you can use always on or database mirroring. It doesn't matter. This one requires Windows Azure Virtual Network in order to configure such a way that this is a trusted, secure boundary that you can use to have your replicas. And the last scenario is, I have two data centers, two Azure data centers, and I want connectivity between them. A typical customer requirement here is, hey, I have global presence for my application. I want someone in Southeast Asia and Europe to access the data, and I want to synchronize the data. Whenever they update, I want this synchronized here and vice versa. Well, SQL Server Always On allows you to do this as well, right? All these three scenarios are possible today, right? So in terms of best practices, actually before we go to best practices, I'll ask Sung to kind of give you a quick run-through of how you address this particular always-on deployment, taking advantage of what Windows Azure provides today, right? So Windows Azure today provides this capability called load balancer, and Sung will speak to you about how you can take advantage of that in SQL Server.
Thanks, Madan. So the Windows Azure gives us this load balancing feature that Madan mentioned. So I've gone ahead and I created a load balance endpoint. As you can see, I named it SQL. It's load balanced with 1433. And this is load balanced with another machine called SungHDW Target. That's part of the same cloud service. So if you look at cloud services here, you can see I have a cloud service named SungHD13, and it contains 4 instances currently. There's a data center, and then these 2 main instances, DW Target and DW Target 2. These are actually participating in an availability group So I think some of you guys mentioned that you had used this before, but it's basically like database mirroring. So you have these two instances that are part of an always-on availability group, and they are having one of these databases, load balance demo app, is replicated across both of these instances. And you can see this is healthy, and this database is a pretty basic database. It just has a single value on it. And what you can see here is if I go to this application, I created a very simple script. All the script does is it connects to the cloud service that I just showed you, and it runs a really basic query. First of all, it selects which server name it's currently connected to, and then it actually just pulls all the data from this table that I created. It sleeps for a second, and then it just keeps looping over and over and over again. So if you see me run it, it looks like this. And you can see here it's connecting. And you can see it's actually already switching between these two instances because I created that load balanced endpoint. And you can see it alternates between the DW target 2 and DW target 1. And this is without even specifying anything special, right? You actually didn't even have to do anything new in your connection string. You get this kind of for free by using this load balanced endpoint. But the neat part about this is because you are in an availability group, you can now insert. I'm connected to my primary replica on this machine. You can now insert data into it. Insert succeeded. And you see automatically, both replicas are now pulling the inserted data without you having to do a single piece of work. So this is only for read workloads, of course, because these are both set up as readable secondaries. You can't quite use load balancing with write workloads, because write workloads, if you use an availability group, can only go to a single primary machine. But if you actually have a small farm set up where you're doing like reporting or these other workloads where it's primarily just read, you can do advanced stuff like this and have Windows Azure automatically load balance for you. And this is real load balancing too. Like Windows Azure will do detect and make sure it round robins across it, across your instances. So this is load balancing as a service basically that we're providing you through Windows Azure. That's a very powerful thing.
All right. So as you can see, I mean, the key point that I want to kind of highlight that is you're essentially using load balancer as a service, right? So this is something if you want to do the same scenario on-prem, you probably have to buy a F5 load balancer or implement a software load balancer. Tremendous amount of work. Now what Windows Azure allows you to do, just like charging by the minute, is use the load balancer as a service in combination with what you already have in SQL Server. And now suddenly you have both availability as well as scalability, right? Anyway, so let's quickly go through the best practices, right? From a SQL Server high availability and disaster recovery, note that the Azure SLA for availability is only if you use 2 virtual machines. It's not for a single virtual machine. What this means is you have to use some sort of SQL Server high availability, whether it's database mirroring or always on. So that's the fundamental thing that you want to think about when you move production workloads, right? If you care about availability, implement SQL Server high availability, right? And when you do implement high availability, make sure that you're setting this up in the same affinity group, which is a Windows Azure term, to specify that all your resources, your storage account, your network resources are close to each other. So you're not paying the penalty in terms of going back and forth. Same thing for availability set and the virtual network. So the key point here is put all of these resources that are together in the same boundary. So you're not paying the penalty in terms of performance. Same domain, same cluster if you're using always on availability group. Again, if you put them in a separate cluster, you're going to kind of go through all kinds of hops to get to your replica. You don't want that, right? And note that Windows failover cluster instance configuration is still not supported in Windows Azure. So always on has 2 modes. SQL Server always on has 2 modes. One is the shared failover cluster instance mode, and another is the direct attached always on availability group mode. The latter, the always-on availability group, is what is supported in Windows Azure. And I talked about this. If you are using multiple disks, be aware that the Azure geo-replication does not support synchronization across multiple disks or multiple page blobs. All right, so let me quickly go through. We're running a little slow in terms of time. Connectivity best practices. Clearly, things are running in the cloud. The only way you can get access to the cloud is by connecting to that. So your connection to Azure is super critical, right? And there are some best practices here. when you're creating your assets in virtual, in Windows Azure, whether it's virtual machines or web roles, worker roles, make sure that you're not creating a whole lot of endpoints that you're not using. These are your entry points for connectivity, but also your points for attack, right? So, these are exposed to internet, so you want to make sure that you're opening the right ports and just that one, right? If you have unused ports, constantly go through and recycle them. Use virtual network instead of just exposing a public remote desktop port. The reason we say that is the virtual network is a trust and a security boundary. When you define a virtual network with Windows Azure, all it does is expose a single public IP that potentially you can secure it. But if you don't use a virtual network, every single thing, every single VM is exposed to the internet, something that you probably don't want, right? And again, installing a virtual network around your VMs is something that is pretty easy done from Portal or PowerShell. And use VPN tunnel where appropriate. So this is an even further step. In addition to doing a virtual network, if you care about connectivity to on-premises, you can use a site-to-site virtual private network, which means that none of these IP, you can essentially say, I don't want any other IP to be exposed to internet. I only want it to go through the secure tunnel. You could do that, right? So this is an extra security boundary. Essentially, you're taking your on-premise secure trust boundary and expanding it to the virtual machines in Azure, and no one else would get to see it, right? Not even us, not even Microsoft that is actually running the machine, besides anything outside the virtual machine, we won't be able to know what's running in the virtual machine. Carefully plan the virtual network. I talked about it. There is currently some deficiencies in the Windows Azure capabilities that once you deploy certain settings in virtual network, if you change them, you have to redeploy them. So obviously, it's costly in terms of configuration and setup. Use availability sets and availability groups. We talked about it. Don't be in the illusion that the VM will be always up. It's not. You can use the mixed mode authentication when not in a domain. Like the SQL authentication is something that obviously, if you so choose to do, you can do it. And the security best practice, I wanted Sung to kind of quickly run through this.
Sure, I'll go through this really quickly since we're kind of technically out of time. But Windows Update is turned on by default, which is good from a security standpoint, but bad from an availability standpoint. So please keep that in mind. Make sure you also turn on SQL updates. We don't turn this on by default, so if you want it to be updated automatically, please enable this. And of course, be aware that sometimes you require reboot. Strong passwords. These virtual machines are inherently publicly available, right? So when you create a virtual machine, it actually has public endpoints. So please use very strong passwords because you want to make sure you protect them, or make sure you have closed all the public endpoints if you're not protecting them. You can still use SQL authentication, but one of the benefits of actually using SQL Server in a Windows Azure virtual machine is you can use your Windows authentication. And this is actually stronger. So in general, you should use Windows authentication where possible. But if needed, please keep in mind that you can also use SQL authentication, and remember, please use strong passwords with that as well, too. If you are connecting to the database from the public, through a public endpoint, make sure that you're turning on the SSL encryption so that your data that you're sending over is not going over unencrypted over the wire. And make sure you have a key rotation policy. Again, since these virtual machines are potentially publicly available, or publicly accessible, make sure that you have a regular policy of updating and rotating any keys that you're using in SQL Server. For example, the root of the SQL Server encryption hierarchy is the service master key. And so the simple command to regenerate the service master key is simply alter service master key regenerate. And we recommend that you do this regularly to make sure that all of your data is protected and secure.
All right, thanks, Sung. So hopefully, this was valuable for you. The slide is available for download, and Sung and I will be hanging out here if you have any further questions. Thank you for coming.